Hello everyone, it's an honor to present our CVPR work, Look Closer to Supervise Better, One-Shot Font Generation via Component-Based Discriminator. An ideal few-shot font generation system can greatly reduce the burden of the font design process. Another application is to create a cross-link group font library. Given the fact that Adobe and Google take years to create a Source Sans font, a universal font style that supports Chinese, Korean, and Japanese simultaneously. However, due to massive Chinese characters, varied font styles, and complicated glyph structures, few-shot font generation still remains a challenging research issue. Early methods view few-shot font generation as an image-to-image translation task. However, they have to be retrained for another new style. Later, some methods are generalizable to unseen styles by performing style and content disentanglement, but the results are still not promising. Lately, several methods utilize the idea of compositionality. Although these methods advance by successfully encoding the diverse local styles, the capability of cross-link group font generation is entirely beyond their reach. To better tackle the FFG issue, we rethink the following two questions. What determines people's judgment on font styles, and how do people learn to write a new glyph in the correct structure? To answer the first question, we present a test string in 3 different font styles. Since their overall architectures are similar, we naturally pay more attention to component parts. As for the second question, people usually learn a new glyph by first learning its components. Such a human learning scheme is perfectly adopted in our proposed CAM, supervising the generator at the component level for both styles and contents. During training, CAM aims to feedback more fine-grained information to the generator by backpropagation, encourage the generator to focus on 3 critical aspects: style consistency, structural correctness, and image authenticity. Here we present our architecture design. The generator aims to implement style and content disentanglement at the component level. The style encoder and content encoder are employed to extract the style and content representation. We conduct add-in operation for style rendering. And finally, the mixer is employed to integrate the style and content and reconstruct the target image. A unit-based discriminator is also employed to perform per image and per pixel discrimination. We introduce CAM to supervise the style and content at a more fine-grained level. It first starts with the component extraction process to supervise the correct glyph structure. Specifically, the feature encoder first extracts visual features from the input image. Then, the decoder employs an attention mechanism for component extraction, acting as a loss function to supervise the structural correctness. The structure retention loss can supervise the content encoder to actively decompose the content representation at the component level. Then, we utilize the attention maps as the labels of component regions for further discrimination. The style classifier performs the style classification on both a per image and per component basis to supervise both global and local style coherence, denoted as the style matching loss. Notably, the style matching loss results in a more powerful style encoder, which can accurately encode local style patterns without accessing the corresponding component labels. Furthermore, a discriminator is additionally employed to classify each component patch into being real or fake, further supervising the local realism of the generated image at the component level. Essentially, our goal is to seek an algorithm that can effectively enhance the generator. Different from previous studies struggling to increase the complexity of generator, we aim to perform more exact supervision for a relatively simple generator to achieve its full potential. Our generator is able to capture local style patterns without implicit dependency on the component categories, showing remarkable cross-link group font generation abilities. In the one-shot font generation task, CGGAN achieved the best performer for both seen styles and unseen styles. Notably, with just one shot, CGGAN still outperforms the second best LF A shot. The visual comparison shows that our CGGAN can better satisfy both style consistency and structural correctness. And here we present our demo. Furthermore, CGGAN can be directly applied to handwriting generation tasks without any adjustment. Our proposed method shows comparable performance with the state-of-the-art under both writer-relevant and writer-irrelevant scenario. We perform linear style interpolation between 2 random styles. The result indicates that CGGAN can generalize in the style latent space rather than memorizing some specific style patterns. Our framework can be further extended to the syntax editing task. CGGAN can robustly edit contents with different lengths, even in the challenging cases, such as complex background or curved text. Code will be available on our GitHub homepage. And that's all we have for today. Thanks for watching.